Hello and welcome to Chapter 3, Section 3. Today we're going to talk about corresponding parts of congruent figures are congruent. Right now we're working on building proofs. We know that it's true that if two figures are congruent, then the corresponding sides are congruent and the corresponding angles are congruent. If we have two shapes, and I tell you that these are congruent, then you know this and this are congruent, and that are congruent. All of the corresponding pieces are individually congruent as well as the entire shape. So if we were to look at triangle ABC and triangle XYZ, and I told you that ABC was congruent, triangle ABC is congruent to triangle XYZ. If you know that, then you know that angle A is congruent to angle X and angle C is congruent to angle Z. You also know that line AC is congruent to line XZ and so on. You can rotate this shape, you can flip this shape over, and they will still be congruent. However, it makes it more difficult to find the corresponding angles and sides that way. And that's going to be some of the work that you're doing. So if you were to look at Explain 1, it tells you that angle ABC is congruent to triangle DEF. And it asks you to find the given side length or angle measure. So it asks you to find the side length of DE. That's this angle, this line here. And if you know that these two triangles are congruent and that it looks like ABC has been flipped over to DEF, then you can tell that line AB is congruent to line DE. And therefore, line DE equals 2.6 centimeters. The angle measure of angle B, that's this one, is the same as E, and that's going to equal 65 degrees. So I'd like you to take a moment to practice this kind of thing with numbers 3, 4, and 5 on the following pages. Pause here and come back when you're done. With number 3, no, you can't tell by looking if the triangle was flipped or not. So you've got two triangles that really look like they are isosceles, but you don't know that for sure because you don't have any measurements. So JK could be congruent to RQ or it could be congruent to RP, and you're just not sure. Number 4, line SU is congruent to line VX, therefore line SU is going to be 43 feet. And number 5, angle S and angle V are congruent, therefore angle S is 38 degrees. We have 3 different properties of congruence. We have a reflexive property, which means line AB is always congruent to itself. This is like the identity property that we've studied before. We have a symmetric property, which means vice versa is also true. If AB is congruent to CD, then CD is also congruent to AB. And then we have actually a useful one, which is called the transitive property. If AB is congruent to CD, and CD is congruent to EF, therefore, AB is congruent to EF. And while this makes logical sense and you think you can ignore it, you need this word in your proofs in order to prove that something is congruent because of the entire shape. So let's get into it. So here we've got triangle ABC and triangle DEF. And I'm telling you that ABC is congruent to DEF and that line AB equals line DE. What is the length of line AB? Now, we know that this one is 3x plus 8 and we know that this one is 5x. We can put them equal to each other and then use the math to solve for x. So if we subtract 3x from both sides, we end up with 8 equals 2x and x equals 4. Knowing this, this is 20, and this is 12 plus 8, which is 20. So we can now give the length of line AB or DE. We can do something similar with the angles. If angle A is the same as angle D, which it doesn't look like in my picture, but in the math book it actually does. If these two are the same, we can put these two equal to each other, and we can solve for y. Minus 5y, minus 5y, minus 2, minus 2. So we learned that y equals 9. And then we can stick that in here. 54 plus 2 is 56 degrees. 9 times 5 is 45 plus 11 is 56. Works both places. Try your turn number 6 and 7. Pause here and come back when you're done. For number 6, we know that these two are congruent. We're looking specifically at line LM. So we're going to put 6x minus 13 equal to 4x plus 3, solve for x, and then determine that LM is 35 centimeters. Measure of angle H is the same as measure M, so we can put these two equal to each other, solve for y, and then determine that angle H is 98 degrees. Please let me know if you have any questions. When we use congruent parts in a proof, we need to be able to take things step by step. This is what a proof looks like when you start. You are given some information and a shape. Triangle ABC is congruent to triangle ACD. And you are supposed to prove that D is the midpoint of line BC. So we always start with what we're given. And we're going to do this in a big chart, and you can see the charts that they build in section 3 of this module. We're going to give them what they gave us, and we're going to say that's what you gave us. And then we're going to move to the next spot. That we know that line BD is congruent to line CD because corresponding parts of congruent figures are congruent. We're going all the way back to the very first page of this section's notes. We know this to be true. Corresponding parts to congruent figures are congruent. Now we know that D, we're trying to prove that D is the midpoint of BC. That's what we're trying to prove. And we know that because of the definition of a midpoint. The definition of a midpoint is that D is exactly in the middle of this line because this part of this line and this part of this line are both equal to each other. So pause here, try B and try numbers 8 through 12 and come back when you're done. So for B, you have these two shapes. We have what's given, two things that are given. We are going to say that angle K and angle P are congruent because corresponding parts of congruent figures are congruent. And we know that J is congruent to P because of the transitive property. So if J is equal to K and K is equal to P, then J is equal to P. Number 8. This is given. We know this angle and this angle are equal because corresponding parts of congruent figures are congruent. If these two shapes are the same, then these two angles are the same. And therefore, if these two angles are the same, that's the definition of an angle bisector. Number 9, we're given this, we're given this. We know that these are congruent. We know that these are congruent. Therefore, again, we're going to use the transitive property. This is equal to that, and this is equal to that, and this is equal to that, and so this is equal to that. So they're all equal to each other. Number 10, yes, because if it has the same shape and the same size, it means it has the same outline. Number 11 is yes. If they are congruent, they will have the same shape. And number 12, you are going to have 5 congruent line statements and 5 congruent angle statements. And that's this section, and that's this unit. So if tonight for homework, you have numbers 1 to 27 odd. And then you're going to go on to Module 3's review and Module 3's performance assessments, and then we're going to have a big review for the test. So let me know if you have any questions, and I will see you next time.